Hello, everyone, and welcome to this EcoRebuild LA mini class. My name is Lucas Ann, and I'm a 10th grader at South Pasadena High School. I'll be your presenter for today's session. This is our third class in our Energy and Clean Power mini class series. In our first class, we learned about what energy is and the difference between renewable and non-renewable energy. In our second class, we talked about home clean energy systems and how technologies like solar panels and batteries can help homes generate and use clean electricity. Today, we're going to focus on another important topic, energy efficiency and smart energy use. We'll talk about why energy efficiency matters, how we can improve it in our homes, and how modern technologies can help us save energy while protecting the environment. Energy powers almost everything in our daily lives: lighting, heating, cooling, electronics, and much more. But using an energy wisely is not just about saving money. It also helps reduce greenhouse gas emissions and makes our communities stronger and more resilient. Before we begin, let's take a quick look at today's agenda. First, I'll give you a brief introduction to the EcoRebuild LA initiative, and then we'll dive into today's mini class on energy efficiency and smart energy use. We'll explore six key areas. First, we'll look at why energy matters, how it powers our daily lives, and why using it wisely is important for the planet. Next, we'll explore energy use and waste in buildings so we can see where energy efficiency improvements make the biggest impact. Then, we'll examine energy-saving technologies, including LED lighting, efficient appliances, and smart systems that help us save electricity. After that, we'll see how these ideas come together in smart homes and community solutions like smart grids and demand response programs. We'll also cover renewable energy and future trends, such as solar power, battery storage, electric vehicles, and AI-driven energy management, which are shaping sustainable communities. Finally, we'll wrap up with key takeaways and actions, highlighting what everyone can do to save energy and reduce emissions in their homes and communities. By the end of this class, you'll have a clear understanding on how energy efficiency and smart technologies can make homes, neighborhoods, and cities more sustainable. And at the end, we'll have a Q&A session. Please type your questions in the Zoom chat, and we'll go through them together, share our thoughts, and discuss any ideas that you have. So, who are we? Well, EcoRebuild LA is an initiative founded by students who believe climate challenges need real, practical solutions. After seeing the impact of disasters like wildfires in our communities, we felt we needed to do more than just talk about our problems. So we decided to learn, share what we discover, and most importantly, take action. Our work focuses on sustainable rebuilding, green technology and solutions, and helping communities become stronger and better prepared for the future. So, why does energy matter? Well, energy is everywhere in modern life. Every time we turn on a light, heat our home, or charge our phone, we're using energy. Buildings, homes, schools, and offices use a huge amount of electricity. In fact, around 30 to 40% of global energy is used in buildings. By using energy more efficiently, we can lower our electricity bills, reduce pollution, and help fight climate change. Even small changes, like switching to LED lights or using a smart thermostat, can add up to big savings for our homes and the environment. Now that we know why energy is so important in our daily lives, let's look at how global energy demand is rising and why it's becoming a bigger challenge. Global energy demand has been rising steadily over the past several decades. As populations grow and cities expand, more homes, offices, schools, and transportation systems require electricity and other forms of energy. At the same time, our daily lives are becoming more dependent on technology. Devices such as computers, smartphones, air conditioning, heating systems, and electric vehicles all require power. As a result, electricity consumption continues to increase around the world. One important fact is that buildings account for a very large share of global energy use, around 30 to 40%. This includes energy used for heating, cooling, lighting, appliances, and electronics in homes, offices, and commercial buildings. Because buildings consume so much energy, improving energy efficiency of buildings is one of the most effective ways to reduce overall energy demand and greenhouse gas emissions. Simple improvements, such as better insulation, energy efficient lighting, and modern appliances, can significantly reduce how much electricity a building needs while still maintaining comfort. In other words, energy efficiency allows us to support growing energy needs while reducing environmental impact. Understanding the growing demand helps us see why energy efficiency matters. Next, we'll define exactly what energy efficiency means and how it can help us use less energy without losing comfort. Energy efficiency means doing the same task while using less energy. In other words, we can maintain the same level of comfort, lighting, heating, or cooling, but with lower energy consumption. For example, a modern LED light bulb can produce the same brightness as a traditional incandescent bulb while using about 75 to 80% less electricity and lasts much longer. This means we save both energy and money. Energy efficiency also focuses on reducing unnecessary energy waste. In many homes, energy is lost through poor insulation, air leaks around doors and windows, or outdated appliances. When these problems are fixed, homes can stay warmer in winter and cooler in summer without using extra energy. Advances in technology have made energy efficient solutions much more accessible. High efficiency appliances, smart thermostats, improved building materials, and better lighting systems all help reduce energy use. Improving energy efficiency not only lowers electricity bills, but also reduces greenhouse gas emissions and helps build a more sustainable and resilient energy system. Energy efficiency can be applied in many different ways, and one of the best places to start is in our homes. Let's take a closer look at where energy is actually used in our homes. In most homes, energy is not used equally. Some systems consume much more than others. Heating and cooling usually take the largest share, often around 40 to 50% of total energy use. This includes keeping the house warm in winter and cool in the summer. For example, running a furnace or air conditioner for just a few hours a day can use more electricity than all the lights in the house combined. Water heating is another significant energy user, accounting for roughly 15 to 20% of a home's energy. Showers, baths, dishwashing, and laundry all add up. Switching to a more efficient water heater or using less hot water can save a lot of energy. Lighting may seem small, about 10% of home's energy, but replacing traditional bulbs with LEDs can still reduce electricity use significantly over a year. Appliances and electronics like refrigerators, washing machines, computers, and TVs use around 20 to 25% of energy. Smart usage, energy efficient models, and unplugging devices when not in use can help reduce waste. By understanding where energy is used, we can focus on the areas with the biggest impact. This way, efficiency improvements aren't just good for the planet, they also save money and make homes more comfortable. Now that we know which systems use the most energy, it is important to understand why so much energy is wasted and what causes inefficiency in buildings. Many buildings waste a lot of energy due to inefficient design or outdated systems. For example, poor insulation allows warm air to escape in winter and hot air to enter in summer. Even small air leaks around windows, doors, or vents can cause a house to lose 5 to 10% of its heating or cooling energy. Older heating, ventilation, and cooling systems, what we call HVAC, often run continuously but deliver less effective heating or cooling. This not only consumes more energy, but also costs more on monthly bills. Old appliances like refrigerators, water heaters, or washing machines can also waste significant energy. For instance, a refrigerator from 15 years ago can use 3 to 4 times more energy than a modern energy efficient model. By identifying and fixing these energy wasting areas, improving insulation, sealing leaks, upgrading HVAC systems, and replacing old appliances, homeowners can save energy, lower bills, and reduce greenhouse gas emissions, all while keeping the home comfortable. Fixing these energy wasting issues often starts with better building design. In the next slide, we'll explore strategies that make homes more efficient from the ground up. Energy efficiency often begins before a home is even built, with smart building design. High quality insulation in walls, roofs, and floors helps maintain a stable indoor temperature. In winter, it keeps heat inside. In summer, it keeps heat out. This reduces the need for constant heating or cooling. Energy efficient windows, like double or triple pane glass with low emissivity coatings, can dramatically reduce heat loss in winter and heat gain in summer. Even small upgrades to windows can lower energy bills significantly. Passive solar design is another important strategy. By carefully placing windows and overhangs, a home can capture sunlight for natural heating and lighting during the day, reducing reliance on electricity. For example, south-facing windows in the northern hemisphere can let in winter sun while minimizing overheating in the summer. Good ventilation ensures fresh air without wasting energy. Heat recovery ventilation systems can bring in fresh air while keeping indoor temperature stable, saving energy and improving air quality. Together, these design strategies can make a home 30 to 50% more efficient, more energy efficient than a typical building. That means less energy consumption, lower bills, and a smaller carbon footprint, all while keeping the home comfortable year round. Once the building is designed efficiently, we can also focus on specific technologies inside the home, like lighting and appliances, that further save energy. LED lighting is one of the easiest ways to improve energy efficiency in buildings. Compared with traditional incandescent bulbs, LEDs can use 80 to 90% less electricity while providing the same brightness. They also last much longer, often 15,000 to 25,000 hours, which reduces replacement and maintenance costs. In addition, LEDs produce much less heat, making lighting systems more efficient and helping reduce cooling needs, especially in warmer climates. Now that we understand how LED lighting can save energy, let's look at other home appliances that can help us use electricity more efficiently. Modern home appliances are much more energy efficient than older models. Many products with Energy Star certification meet strict energy efficiency standards set by the US government. Efficient refrigerators, washing machines, and dishwashers use advanced motors and smart controls to reduce both energy and water consumption while maintaining strong performance. Induction cooktops are another example of efficient technology. They heat cookware directly using electromagnetic energy, which makes cooking faster and wastes less heat compared to traditional gas or electric stoves. Upgrading to energy efficient appliances is a practical way for households to reduce electricity use and lower utility bills. Speaking of efficiency, smart energy systems take energy savings a step further by automatically managing electricity in real time. Smart energy systems use sensors, data, and automated controls to manage electricity more efficiently in buildings. These systems can monitor energy use in real time and adjust lighting, heating, and cooling automatically. For example, motion sensors can turn off lights in empty rooms, while smart thermostats can adjust temperature based on occupancy and weather conditions. Some modern systems also use AI and smart home technology to analyze energy patterns and optimize energy use over time. By reducing unnecessary energy consumption, smart energy systems help lower electricity costs while improving overall energy efficiency. And one of the most visible applications of smart systems is smart thermostats, which can adjust temperature based on your routine. Smart thermostats are a common example of smart energy technology in homes. They can learn user habits and daily schedules and automatically adjust heating or cooling to improve energy efficiency. For example, the system may lower heating or cooling when people leave home and start adjusting the temperature before they return, keeping the house comfortable while using less energy. Many smart thermostats can also be controlled remotely through mobile apps, allowing homeowners to monitor and manage energy use anytime. By optimizing temperature settings and reducing unnecessary heating or cooling, smart thermostats help lower both energy consumption and electricity bills. Home energy monitoring systems let you track electricity use in real time, often through smart meters or mobile apps. They can break down energy consumption by appliance so you can see which devices use the most power. These systems often provide alerts or reports, helping homeowners notice unusual energy spikes or wasted electricity. For example, you might find that an old fridge or a constantly running water heater is consuming a lot of energy. By understanding your daily usage patterns, you can make smarter decisions such as running appliances during off-peak hours, adjusting thermostat schedules, or upgrading to more efficient devices. Overall, energy monitoring not only helps reduce electricity bills, but also supports a more sustainable and efficient home. We've seen how individual devices save energy. Next, let's explore how these technologies come together in a complete smart home. Smart homes integrate multiple technologies to manage energy more efficiently. Lighting, thermostats, and appliances can be automated or controlled remotely through mobile apps or voice assistants. For example, lights can turn off automatically when no one is in the room, smart ovens can preheat only when needed, and thermostats can adjust based on occupancy and weather. Some systems even analyze energy patterns over time and suggest ways to reduce consumption. By combining these technologies, smart homes and not only reduce energy waste but also make managing energy use more convenient and cost effective for residents. Beyond the home, the same principles apply at the community and city level with smart grids and demand response programs. Smart grids are advanced electricity networks that use digital technology to monitor and manage electricity flow in real time. They help balance supply and demand so electricity is used more efficiently and blackouts or overloads are less likely. Smart grids also make it easier to integrate renewable energy sources like solar panels, wind turbines, by automatically adjusting for fluctuations in production. Some smart grids can even communicate with smart homes and buildings, allowing energy to be stored or shared when needed, which further reduces waste and improves reliability. By combining digital monitoring, automation, and renewable integration, smart grids help create a more sustainable and resilient energy system. Demand response programs help balance electricity supply and demand by encouraging users to shift energy use to off-peak hours. For example, running appliances like washing machines, dishwashers, or electric vehicle chargers at night reduces peak electricity demand, which helps prevent grid overloads and blackouts. Some programs provide financial incentive, like lower electricity rates during off-peak hours, encouraging households and businesses to participate. Demand response also supports renewable energy because it allows the grid to better handle fluctuations from solar to wind generation. Overall, by spreading out energy use more evenly, demand response improves grid reliability, reduces energy waste, and can lower costs for everyone. After looking at current energy saving technologies, it's important to see how they work with renewable energy for maximum impact. Energy efficiency becomes even more powerful when combined with renewable energy. Solar panels can generate electricity during the day, while batteries store excess energy for use at night or during peak demand. EVs can also participate in energy management. Some EVs can store electricity and feed it back to the home or grid when needed, a concept called vehicle to grid. Smart energy systems can coordinate solar panels, batteries, and EVs to optimize electricity use, reduce waste, and lower costs. By integrating these technologies, homes and communities can rely more on clean energy, reduce fossil fuel use, and move toward a more sustainable energy future. Net zero energy buildings are designed to produce as much energy as they consume over the course of a year. This is achieved by combining energy efficient design, renewable energy sources, and smart energy systems. Many new homes, schools, and office buildings are targeting net zero goals to reduce carbon emissions and save on energy costs. Certifications like LEED, Leadership in Energy and Environmental Design, and WELL recognize buildings that meet high standards for energy efficiency, water conservation, and indoor environmental quality. California has been a global leader in energy efficiency policies, requiring new constructions to meet strict building codes, insulation standards, and renewable energy requirements, pushing the market towards sustainable net zero homes. Some examples include solar panels on rooftops, efficient appliances, advanced insulation, and smart energy monitoring systems, all working together to reach net zero energy use. Finally, let's take a look at the future, how AI, smart cities, all work and advanced batteries will shape energy management in the years ahead. In the future, artificial intelligence will play a key role in managing energy use. AI systems can analyze consumption patterns in real time, predict demand, and automatically optimize electricity use for homes, businesses, and communities. Smart cities will integrate energy efficient buildings, transportation systems, and renewable energy into a connected network, improving efficiency and reducing emissions on a large scale. Advanced battery and storage technologies will allow renewable energy from solar and wind to be stored and used when needed, increasing grid reliability and reducing reliance on fossil fuels. Together, these trends will make it easier for communities to save energy, lower costs, and create more sustainable, resilient urban environments. To summarize, energy efficiency is one of the most simplest and most effective ways to reduce energy waste, lower electricity bills, and cut carbon emissions. Small changes like switching to LED lighting, energy efficient appliances, or smart thermostats can make a big difference. Smart technologies such as automated lighting, smart appliances, energy monitoring systems, and AI managed grids help us use energy more efficiently without extra effort. Combining energy efficiency with renewable energy, battery storage, and electric vehicles further reduces reliance on fossil fuels and supports a more sustainable energy future. Most importantly, everyone can contribute. whether it's changing daily behaviors, upgrading home devices, or learning how to manage energy wisely. Even small actions add up when entire communities participate. Thank you so much for joining this EcoRebuild LA class. By applying what you've learned, you can help create smarter, cleaner, and more sustainable homes and communities. So that's it for today's Zoom session. Now we'd love to hear from you. If you have any questions, just type them in the Zoom chat and we'll discuss them together.